So in the second task, we are going to construct a portfolio, allocate 60% of portfolio to Amazon and 40% to Ford. Um, so the question asks, what is the weighted average return and risk of the portfolio, and explore different allocation percentage for Amazon and Ford, like 70%, 30%, or 50-50 to calculate the resulting portfolio risk and return for each scenario, and identify the optimal allocation strategy based on risk-return trade-off. So finally, evaluate historical performance portfolio over 5 years, calculate metrics such as Sharp Ratio. So let's have a look at the formula that we can find out risk and return of the portfolio. Remember, the return of portfolio is simply weighted average return of individual stocks in the portfolio. Okay, so if I back to my Excel sheet, and now I want to focus on my portfolio. So let me, for now, put this one besides and focus on our portfolio. And the first step, let's allocate the weights based on the question. It's going to be 30%, 70% or 60% for Amazon and 40% for Ford. So I'm going to allocate 60% to Amazon and 40% to Ford. But because I wanted to keep changing this one, let me change it with the change the color to red to make it more distinguished. So basically, the sum of the weight allocated to each stock in our portfolio should be equal to 100%. So I can say this one is equal to 1 minus 60%, right? This is what we can say. So if I change this one, for example, to 70%, the other one would be 30%. So for now, let's keep it 60% simply. So what is the mean or return of portfolio, daily mean or return of our portfolio? Simply is equal to weighted average of individual stocks in our portfolio, right? So it is to say that return of our portfolio is equal to the return of Amazon times 60% plus return of Ford times 40%. So we will end up with this number. So I'm going to reduce the decimals. So 0.066. As you see, this number is always between, these two, the return of Amazon and Ford, all right? Because it is basically weighted average. And if I change the weight, this one will be changed as well. But what is the risk of the portfolio? The risk of portfolio is not simply weighted average standard deviation of individual stocks in your portfolio, but we need to follow another formula. So portfolio variance basically is equal to weight of asset 1 in power of 2 times variance of asset 1 plus weight of asset 2 in power of 2 times variance of asset 2 plus 2 times weight of asset 1, weight of asset 2 times covariance between these two. And remember, covariance, so instead of covariance in this formula, we can put a correlation, but remember the relation between correlation and variance and covariance. So correlation between stock 1 and 2 is equal to their covariance over their standard deviation multiplication of their standard deviation, all right? So we can basically put this sigma 1, sigma 2 times P1, P2 in this formula instead of covariance. And to end up with the portfolio standard deviation, we need to take a square root. So as I said, instead of this, you can put this relationship, 2 weight of 1, weight 2 times weight of asset 2 times correlation between these two times their standard deviation of 1, standard deviation of 2. So let me back here and try to type this one. So we can say that the risk of our portfolio is equal to weight allocated to Amazon in power of 2 times a standard deviation in power of 2. A standard deviation power of 2 is equal to variance simply, plus weight allocated to Ford in power of 2 times standard deviation of Ford in power of 2 plus 2 times weight allocated to Amazon times weight allocated to Ford times covariance between these two or correlation of these two times their standard deviation. Standard deviation of Amazon times the standard deviation of Ford. Okay, so we need to follow this approach and this formula to end up with the variance of our portfolio. But what we are interested is a standard deviation, and a standard deviation is a square root of variance. So I can add another function, sqrt, and put all this formula inside the sqrt to end up with the standard deviation of portfolio. In that case, the unit is percentage, and that will be the risk of our portfolio. All right. So now the question asks, what if we change the weights? Let's say, for example, change this one to 70%. So as you see, the portfolio risk and return is changing. And as such, this metric of return to risk, which is another version of Sharpe ratio, is changing as well, right? Let me change this one to 50% or 60% or 30%. As you see, when we change the weights, the portfolio risk and return is changing and Sharpe ratio is changing as well. All right. So it's very important for us not only select the best weight of allocating our asset to different stocks. I mean, weights and finding the optimal weight is important, but also finding the best correlation matters. If I change the correlation, I mean, assuming that correlation of these two was like, for example, a 0. So it would change. The portfolio risk and return also would be changed, right? So there are different factors we need to take into account with we construct a portfolio, the weight allocated to each asset, and also the correlation between these two. All right. So now how we can find out the optimal weight allocated to each of these two. So there is one way we can use in Excel using Solver. So if you go to the data, panel data, it should be another sub-panel called analysis, and Solver should be there. If you don't have this one, you need to go to File and select Options. And here, go to Add-ins, scroll down to Add-ins, and press Go here, and tick Solver add-in, and press OK. In that case, you would have data analysis, all right, and Solver here, basically Solver. If you want data analysis, you need to tick data analysis as well. So now we click Solver. So our goal here is to do what? Set objective. We need to refer to the cell that is our objective. Our objective is to maximize this cell, the value attached to this cell, because this is the ratio of the return to risk. And we want to have higher return per 1 unit of risk. So we want to maximize it. How this number would be changed? This number would be changed by changing this weight, right? Because if I change this one also would be changed, right? Do I have any constraint? Yes, I have got a constraint. Let me close this one. My constraint is that sum of these two should be equal to basically 1. Always, always, right? The sum of these two weights, or the weights of allocated to a portfolio, should be equal to 100%, or basically 1. So let's back to the data solver. As I said, we set the object, we set the value to be changed, and now we are going to add constraint. The constraint is that this cell should be always equal to 1, and then press OK. All right, so next we solve it. So as you see, the number changed to 66 and 34, and keep solver solution. Okay, so basically Excel tried different combination of weights to find out with the best weight or optimal weight, which maximized this number, which is now 0.0335. If I change this number to any other number, like say even 65, this number most likely will be changed. If you increase decimals, you would see that definitely this number has changed to, for example, let's go 66. It's decreasing, right? If I change it to 50, it's decreasing as well. So the best optimal combination according to solver, if I solve it again, keep the answer, is 66% weight allocated to Amazon and 34% to Ford.